This must be what's like to have some kind of psychotic episode. On that note, let's have a podcast.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 230. This week we'll be talking space science, superconductors, supercapacitors, and central air. This week in science news, we've had the reports of a room temperature superconductor, LK99, and we were debating whether we should write it up or not because we can't tell. We have no idea. Anyway, Jenny finally wrote it up after another lab has reported to have replicated the synthesis or whatever. They're making like hyper extraordinary claims and it worries me. I'm like super skeptical. And then I went to read the paper and I do not understand superconducting material science at all.
Well, that's good because I was worried when I saw this on the agenda that I was going to be the only one on the podcast who doesn't understand superconductors.
I have no ability to judge any of this science. None.
Yeah, talk about outside of our wheelhouse. But I mean, you're right. Everybody's going crazy about this. I was looking it up this morning, and like every site is running something about this. There's like this mad rush to duplicate or disprove the results, and it seems like so far the consensus is that it levitates, which is cool, but is not the only. That's a side effect of superconducting, but not in itself enough to prove. Like I saw somebody said it doesn't disprove that it's superconducting, but it doesn't prove it either. So it's interesting, but I mean it's a very exciting thing, right? I mean, we had a little talk in our weekly meeting, like what would superconductivity do for you? I think that's a scramble now, right? Like if you really have it, what can we do with it? And in theory, if you can make wires out of it, you'd have no losses and that kind of stuff. But I think that was also one of the tricky ones with this is that this is like a ceramic, if I'm understanding it correctly. So there was some question that like, okay, even if it is a superconductor, ceramic isn't like the ideal. They'd have to figure out how to apply it. It would be difficult to do the superconductivity things they want to do with it, but that's kind of putting levitation in front of the horse, right? Like you still have to prove it's a superconductor.
I read a nice tweet by a material scientist that says there's kind of a couple scenarios. If it saturates at basically low field strength, so it can't pass much voltage, and saturates at low current, so neither capable of holding high voltage or high current, then it's probably reasonably useful for things like telecom and cell phones and electronic sensors and satellites and CPUs and antennas and, small things like that. On the other hand, if it can carry a bunch of current, there will be like power transmission and switches and relays and stuff. And then if it can do high voltage and high current, it's going to be electric motors, electric trains, real energy storage, all the real like heavy stuff. And so the jury is not only out on whether this is a superconductor yet, but on at what level it saturates and becomes no longer superconducting. And so all of this is like a big we'll see, but who knows? Could be the turn of the corner.
It also seems like a part of it is that it's easy to make in the grand scheme of things. And I'd even seen somebody say that this is not like outside of like home lab stuff.
Right.
So I think that's part of like why these other labs are able to, would they drop the paper on Friday and,
right.
We're less than a week away in our time adjusted recording. You already have other labs, releasing their report because they were able to spin it up so quickly. And somebody in the comments on one of our posts said that somebody on Twitter was trying to make it, and they were like live tweeting or live Xing. Well, not live Xing. That's not. You can't say that. They were live something the experience, but then I went and tried to look at it, and I don't have a Twitter account, so it wouldn't show me. So that was fun. Thank you.
If this does end up being the most revolutionary thing ever, it'll still be that next year. It doesn't matter
get the funding this year.
It doesn't matter if you replicate this week or next week. It's really, it's not going to matter in the grand scheme of things. This is a weird, like, hypey way to do science, and it reminds me of cold fusion a little bit. So, I'm trying to damp everybody down here. Damp down. Science will be done and must be done, but, all in due process.
Yeah, that's a side effect of our instant gratification lifestyle anymore, I guess. I mean, I saw one of the scientists that did a look at it in their own paper. They posted the paper on Twitter with the Obama mic drop gif.
Oh, good Lord.
Like, this is where we're at now. That scientific papers have to have memes attached.
Yeah. All right, so let's talk some real science. ESA's Euclid Space Telescope and the quest for dark energy. Maya wrote this up this week. I guess Euclid is another infrared telescope, similar in a lot of ways to the James Webb, except it's dedicated to looking at the cosmic microwave background and trying to figure out how much dark energy there is out there. It's also orbiting around the L2 Lagrange point. It just fired up a few days ago, and the first photos are back, and everything looks good. So that's really interesting. And the hope here is that they will be able to nail down the Hubble Constant, which is important for figuring out how fast the universe is expanding. I'll post a write-up from Moritz Sievers from 2021 about the Hubble Constant controversy. There are kind of these two competing ways of measuring it. One is what Euclid's doing, which looks at the cosmic microwave background, and the other way is to look at stars, guess how far they are, and then look at the redshift to figure out how fast we're moving away from them and how fast the universe is expanding. At the end of the day, the cosmic microwave background measurements and the ladder-based distance measurements of the Hubble constant have both refined themselves very, very well. They're getting multiple consistent results, and unfortunately, they cluster around two entirely different values. And so this is horrible because the Hubble constant is being measured two different ways, and they really should give the same answer. And they're both getting their confidence intervals down so that they no longer overlap with each other, and it looks like they're just really different. So Euclid is going to give us a lot more stronger data on the cosmic microwave background measurements, and hopefully, tighten that one down. But there's still this other way of measuring how fast the universe is expanding, and it doesn't seem to agree.
This is a journey into sound.
What's that sound?
What's that sound?
All right, that brings us to What's That Sound? This week is a Pick the Winners week, and we had a bunch of entries. No, you still don't get off the hook. You still have to listen to the sound and tell me what it is.
I still have to listen to it. Actually, this might be worse, because not only do I have to listen to it, I get to find out immediately how many more people than me knew the answer.
14 people knew the answer better than you did.
Oh, okay. Well, it's like a foghorn, a lighthouse or something.
Exactly what it is.
Right. But I mean, 14, were they looking for the specific foghorn? I mean, I feel like more than 14 people would recognize a foghorn.
I was actually asking if anybody would pick up the actual foghorn, and it's a type G diaphone.
Naturally.
Which is, it's actually I picked this one because it's actually the world's largest foghorn, and there are two of them currently in operation.
I was going to guess it is a leghorn-style foghorn.
That's...
Did anybody send that in?
That's actually what Christina said, believe it or not. Really? She's like, that's a foghorn. And I'm like, which one? She's like, well, it's not leghorn. I'm like, yeah, touche. This is the Lowhead Lighthouse and Foghorn in Tasmania, and it's one of two remaining of these absolutely giant ones. And I'll have to throw the link to the video of it being fired up. It's absolutely fantastic. It's got these two super gigantic pressure tanks, and they fire up these motors that compress air into them, and then they let the thing go. And it just looks like it's a crazy racket. Looks like the coolest thing. If I were anywhere near Tasmania, I would make a trip to go hear this thing in person, because it's pretty damn crazy. 29 answers, 14 of them are correct. I'm going to fetch a random number from the NIST random number beacon. Rolling the dice, the NIST has gotten back to me, and my random number is 6. So that is congratulations to come about, avoid those rocks for the answer, foghorn. Yeah, there were a bunch of great answers in this one.
Like nautical answers. I like.
Yeah, exactly. Including a couple Foghorn leghorns. Anyway, congratulations come about. Avoid those rocks. I will send you an email and get a Hackaday podcast t-shirt out to you. Everybody else, stay tuned next week for your chance to win. All right, well, my first hack this week is a Game Boy camera without the Game Boy. And this is a neat project and a deep dive into the old Game Boy camera by Raphael Boschot. And head on over to his GitHub and you will find this project, which is a Game Boy camera, a Raspberry Pi Pico, an LCD screen, and that's honestly about it. There's an SD card and some voltage shifting stuff because the Game Boy camera is so old it runs on 5 volts and the Pico on 3.3. But what I thought was really neat about this was kind of the dive into the sensor that the Game Boy camera used. It's apparently called the Mitsubishi M6428FP Artificial Retina.
Oh, wow.
It's a 128 by 128 pixel CMOS sensor. And I just love the fact that they had the balls back then to call it an artificial retina. And so he's got linked in his project, of course, he's got the data sheet for it, and it's really interesting to read. When you think about the Game Boy camera, it had I think it had 4 colors, right? It had white, black, and then 2 kind of grays in the middle. It turns out that the sensor actually has 8-bit gray levels. And it's really neat, and it looks like you can set it to work in extraordinarily low light conditions, and it's got all sorts of cool hardware details that I think the Game Boy just didn't take advantage of because it was a very primitive microcontroller at the time. And Raphael takes advantage of a lot of this in his version of it. Plus, he can add all these extra functionalities to this camera, like, time lapse or live recording or motion detecting. He runs it at different exposures to do high dynamic range. He'll do multi-exposures. And some of this is made possible by the sensor itself. And this is actually the coolest / craziest thing is that if you, set some values in some registers, the chip on board does some kind of rudimentary convolutions. And so it can do edge detection and it can do sharpening and a couple other really interesting features for, computer vision on the chip itself. And this back in the early 2000s. And so this makes me give him a little bit of props for calling it an artificial retina because there is some, I guess most of it's going on in the brain, but we do a lot of the same kind of processing in our visual systems. And so there's the Game Boy camera chip doing it too. Anyway, really cool camera build, but then also really cool because it lets him play around with this kind of really old chip, but then push it in all these different directions and explore it and expand on it. And I thought that was really cool.
I think part of it was, like you're saying, obviously the Game Boy hardware was limited, but nobody had used a digital camera at this point, right? Like I think that's
right.
What it's famous for. Like the Game Boy camera was like the first for a lot of people the first practical digital camera you could actually afford. The fewer options probably the better because it had all been Greek to them at that point. But looking at it now with modern eyes, like, I want to have all these like hidden undocumented features like that I can adjust things. And looking at it too, that this build, I'd really like to see bring it all the way and put it in some kind of like 3D printed enclosure or something because it's obviously made to have kind of a DSLR sort of form factor with the controls off to the side and stuff.
Yeah, no, I totally agree. And I hope this does fool a lot of other people into hacking on this thing. And if you want to get into the nitty gritty, you can also dig into an older GitHub of Raphael's Play with the Game Boy Camera Mitsubishi sensor. I'll throw the link for that in the show notes. And there it's his first time working with the sensor and just trying to figure out all of how it works and everything. And that's really an interesting read for the low-level stuff. If you want to talk a little bit about the history of these, and like Tom was saying, this was one of the first kind of mainstream, commonly available digital cameras. There was a really neat video put out by Asianomics earlier this year. I'll link that Inside Digital Image Chips. It's kind of about the CCD versus CMOS war, and the Game Boy is one of the first signs that the transistor density in CMOS chips was going to start taking over the old CCD variety of image sensors. I guess it's kind of a historic camera in that sense.
Yeah, sort of, yeah.
You know,
It's kind of a
despite
big
it
deal.
being super cheesy, it's actually kind of a big deal. And it does look like by putting a real lens on it and getting all 8 bits of black out of it, you can actually get some kind of okay pictures. I mean, again, limited resolution, but you know, what more do you need for doing kind of simple computer vision robotics stuff? And maybe the fact that it has fewer pixels actually makes it easier to process on a Pi Pico, and that makes it easier to integrate into your project. So I think this is really cool, and I love seeing work on things like this that are just kind of at the edge of being so easily accessible now that anybody can play with it. And I think that's really cool.
Well, it's interesting you say that too, because that was the one thing I was kind of surprised. It doesn't appear that this has that the lens adapters that we've seen for the Game Boy camera. We've seen a bunch of those, like the 3D printed lens adapters. And I think if you did like a version 2 of this board with the lens adapter, you would be very close to making like a professional Game Boy camera with, you know, switchable lenses and, you know, proper controls and stuff. So I think we're almost at the end game for Game Boy camera hacks. We've come full circle. Like, you know, say it was one of the first digital cameras, but it was kind of hindered by the Game Boy itself. Now it's evolved past the early years, and it's turned into the professional camera we all knew it was deep down inside. All right, well, my first story this week comes our way from MIT. They're pretty clever guys, and the title of this one, written up by Jenny List, is MIT Cracks the Concrete Capacitor. The idea here is that they are trying to make supercapacitors out of what's basically, you know, your garden variety concrete, with the idea being that you could integrate storage, you know, into buildings. Like you imagine a house's foundation or, you know, concrete barriers on the side of the road or something. They can actually store energy in a really robust and kind of maintenance-free way while also being super cheap, so you don't worry, you know, if a car hits it or something like that. Concrete doesn't strike you as a particularly good energy storage medium, right? So you'd be forgiven for thinking there's some kind of crazy nanotechnology or something going on here. But what struck me with this is how simple it really sounds. It almost sounds like something you could go to the Home Depot and get the stuff for today. And I hope desperately that's the case. I want someone next week to send us in a hack that they did this. But the idea is that they mixed carbon black, which is conductive, into, it says, just regular concrete and regular water, and the end result is that the carbon black doesn't really, you know, it doesn't really mix with the concrete so much as it makes like these tendrils that kind of go through it. The paper actually kind of describes it as like a fractal thing where they branch off into, you know, the end result is they have a lot of surface area. So there's a lot of surface area inside what might be a small piece of concrete. Then with the addition of, I think, potassium chloride as the electrolyte, it makes a capacitor. Like that's the recipe. Like it seems very, very simple. And you know, they have done this only on a very small scale. I think they said they're doing it like the, you know, coin size cell, you know, pieces of concrete, but they were able to push enough energy into them to light an LED. So it looks very interesting. I mean, I think the first question is probably, you know, what are these tendrils of carbon inside the concrete do to the strength, right? Like, you know, you have to think that has some kind of a negative effect. But other than that, I mean, you know, the energy densities they're talking about is pretty impressive when you consider that, like, you need a lot of concrete to do anything anyway, right? You know, no, yeah. If you need concrete, it's not usually like, well, let me get a little concrete. Nobody needs like a handful of concrete. Like if it's concrete, it's probably going to be huge and massive. So you might as well pump some energy in there and use it for storage.
Yeah, and I think that's exactly the point here. This is not, concrete isn't lightweight. This isn't something you want to like use for energy storage for your,
right, your phone,
cell phone
is not
right?
going to have.
Yeah. If you're laying a concrete foundation anyway, you might as well mix in what they're saying, like 3% by volume of just, you know,
huge.
cheap carbon black, and put conductors at either end, and you're off to the races. So I do think that's really cool. I think we kind of overestimate how hard it is to make capacitors and supercapacitors, right? Like if you're thinking about the old school, do-it-yourself capacitor, you can just do it by rolling up some tinfoil and some polyethylene sheet or something together, and you can make a pretty decent capacitor. My absolutely favorite, like low-tech supercapacitor has to be one from Mechanicus from 2016. I'll throw the link. Lint and dog hair supercapacitor. And so what he was doing is basically the same thing here. He was taking the lint and dog hair, putting it in a crucible, turning it into charcoal. And so he's got these long carbon threadules, long carbon tendrils, just like exactly what's going through the cement structure, except here it's just a fine high surface area, bunch of conductive carbon, because he took a bunch of rolled up dog hair and burnt it. So yeah, both high tech and low tech.
Somebody pointed out in the comments, in the original MIT write-up, there's a quote from, I guess, somebody on the team that says, it's a really multifunctional material. Besides its ability to store energy in the form of supercapacitors, the same kind of concrete mixture can be used as a heating system by applying electricity to it. But isn't the applying electricity to it how you get the power in it in the first place? So, does it get hot every time you charge it? I mean, because that could kind of be a problem. I can see the advantage of, a self-heating concrete, but not in August when I'm trying to store power from my solar array. But no, I really would like to see somebody try this, because it does sound, I mean, of course, the devil's in the details, right? It does sound like that's how easy it is, that you could do this in your garage.
All right, my next hack comes in the form of a video from Marktforge. Splitting 3D prints into parts can add strength. If you've played around with 3D printing, this isn't really something that you don't know, but I thought this was a novel solution to the problem, so I wanted to bring it up. Basically, when you do extruded plastic 3D printing, the Z-axis is weaker because the layers don't stick as well to each other as the thin noodles of plastic hold together. And so you've got kind of two strong axes and a weak axis. And if you're making something like the example here is essentially it's a bolt hook that you want to be able to also put on a plate and screw down to a table, you can't print it vertically with the hook pointing up, because then that's going to put the weak layers in the direction that it wants to hold against. And then they're like, well, you could print it sideways, but then the mounting plate is going to be the weak link. And you can't really get around both of those, except you can. The solution they're proposing here is then you split it into two parts. And so you have the hook part on one print, so you print it so it's strong in its strong directions. And then the mounting plate in another print rotated, 90 degrees to that, so that it's strong in all of its strong directions. And I think that was basically what I thought was cool here, is that they did the experiment of printing the whole print flat, printing the whole print on its side, and then printing it in two different parts where they're printed according to their strongest directions. And they get an 80% increase in strength. The way they do it is also kind of cool. They, put a hole in the mounting plate and then a little square cutout underneath, and then, an equivalently shaped part mates with that, and that's what holds the hook part. I guess you kind of have to see the video. In this case, they were able to get away with just press fitting it, but in general, you might have to glue these parts together. Yeah, or just maybe think a little bit harder about how you're going to have the two pieces mate together. I was actually thinking, you could maybe do something with sliding wedges or tapered dovetails or something like that to put the two parts together too, and that'll give you the same sort of material strength without having to worry about glues. It's just one of those things. If you've probably run into this problem in your 3D printing life, if you've ever made anything, mechanical that needs to hold a little bit of strength. And so it's nice to see this solution worked out so cleanly. And, it's just one of those things that now I have in the back of my mind, and I'm going to probably end up using it sometime.
If you've been printing for any length of time, you've probably run into this just by chance, right? And it's obvious, it's a logical thing. You know, it's obviously going to be the weakest where it's stacked up vertically, right? But what I thought was interesting here is that it's so incredibly tempting to just print it the easy way. You know, and I think this is a perfect example of that because, you know, it's a flat plate with a little vertical, you know, whatever you want to call that. 99.9% of people, especially if you've used a 3D printer, will be like, oh yeah, this is great. I'll print it flat on the bed. The flat part will be flat, and then this vertical, no supports, no nothing, and that's what you do, right? And
it's
even
the way
if
it wants to be printed,
right? It's even if you know it's not going to be strong that way, you want to print it that way because it's the easy way, and you know it's the path of least resistance. But like you said, you really to take advantage of this, you really need to change that thought process and be like, I know this is going to be way harder. And probably take twice as long, and now I got two parts, and maybe I gotta glue them, and I gotta figure out the tolerances between the parts, but the end result is going to be so much stronger, you know. And this isn't something you always need, obviously. I mean, it's going to be case by case, but by modifying your own thought process and really playing to the strengths, no pun intended, of the technology, you know, it is really impressive the gains you can get here. And this is something you can run into in real life. It's funny. I was actually talking to somebody yesterday that you know, I had been 3D printing parts for this person for a while, and I didn't mind, but I think they felt some kind of way about it. So they finally bought their own printer and have been, you know, going through the process, and it's kind of fun. It's kind of fun to watch. You know, I forgot what it was like. You know, those early days where like every time I talk to him, he's like, "But it won't stick. Like, why won't it stick to the bed?
God.
It keeps going." He's like, "Have you ever had? It looks like spaghetti." I'm like, "Yeah, I've had that." So you know, I get to watch this like baby 3D printing person, you know, come up. He got into it. It's actually cool. He's like redoing his shop or something, and he's realized the incredible organizational possibilities by making bespoke stuff. And he went on Thingiverse or whatever, and he found these holders. It uses like the battery interface for whatever brand tool he has, Ryobi or Milwaukee. It lets you hang the tools and the batteries on the wall, right? Like say like the battery clips onto it or the tool clips on. And he said like the battery ones worked fine, but when he put the tool on the thing, the print delaminated. And it came apart right on that layer line, and he was like, "Why did it do that?" And I kind of had to explain, just like what you're saying. I was like, "Well, prints are weak where those layers are together, and especially, you know, he might be printing too cold or something." And it was interesting because he immediately, and again, this is a guy who's only had a 3D printer for like a couple of weeks. He was like, "Well, if I printed it the other way, it'd be stronger, right?" And I was like, "Yeah, exactly." Like now you're getting it. Now you're starting to think, you know, think like the machine, right? And even though it'd be annoying to print it that way, and now you're talking about supports and stuff. Yeah, I mean, if they're delaminating under the weight of your drill, you kind of have to approach it from a different way. Although, you know, between you, me, and the thousands of people listening, I think probably his settings are wrong on the printer because like it shouldn't delaminate off the weight of a drill. You know what I mean? Like I've hung way heavier things on 3D printed parts, but.
Oh, I remember when I was starting out, I was so worried about like wasting plastic. I made all these parts that were like super spindly and could barely hold anything. And no wonder, because I was being so stingy with my designs.
Yeah, I saved a gram.
Yeah, exactly. And I didn't realize, but some of that's just a mental thing, realizing that a lot of the strength in a 3D print, it's like monocoque design. It comes from the outside shell being strong, and then the infill doesn't really matter much at all. And so, you know, actually making it bigger doesn't make it much more material, but it makes it infinitely stronger. And that was a big design change in my mind. But then the other one was the layer lines thing, right? And that it has a weak direction and a strong direction. I kind of got serious/good at woodworking after I got into 3D printing. And so I'm like, you know, wood has grain just like 3D prints do, which is, of course, the totally backwards way to think about it. But,
yeah, right.
But, you know, wood behaves this way too. Everything except metal does, as far as I know.
That's such a perfect, like, Hackaday mindset. Like you're 3D printing something, you're like, wait a minute, I could make stuff out of wood too. It's like technological evolution in reverse, right? Like if I got a chisel and I hit a piece of wood with it, I could make a shape.
Wood has grain, just like 3D prints do. Yeah, I'll give you that. The point I was trying to make is that 3D printing is like half the design itself and half thinking about how to work around the materials and what 3D printing lets you do and what it forces you to do and where its strengths and weaknesses are. And that really is different from making stuff out of wood, making stuff out of cast plastic, making stuff out of bolted together pieces of metal. It's just a different, it's just a different project and it needs a different design thought. And this is just one of those clever ones that you should have in your back pocket.
My next one comes from a guy that I always like to see in the tip line. This is How To Lou. And the article in question is turning a window air conditioning unit into a whole house AC. And if you're not familiar with Lou, we've covered a bunch of his stuff. He's a wild guy, and he comes up with these ideas, and you know what? He's gonna do it. And it might not be the best idea, but you're not gonna stop him, right? He's gonna figure it out, and he's gonna do it. And I would say in the vast majority of cases, it does at least get close to his intent, even if it's not maybe the way we'd always approach these things. He's happy. He's always smiling at the end of the video. I'll put it that way. To get back on track, in this case, it says he bought this. I mean, it looks very much like he bought it from a yard sale or something. I don't think he went to the store and bought this air conditioner, but he bought this big window unit air conditioner. But he didn't need a window unit. He had a central heating system, and he basically wanted to adapt the window air conditioner in such a way that he could make a central air out of it. So he took the front panel off of it. He extended the electronics with looks like thermostat wire or something. He extends that like 15 feet into the building. Looks like it's a workshop or a shed or something. It's mounted on the wall like a central air. That part looks pretty cool. And then he cut a hole in the wall and he puts the window unit up to the hole. But then he put a piece of foam between the two coils and hooks ductwork up to them with the idea that, the top cold part he can now duct into his heating system and that the bottom part will suck the air in to be cooled. And he's obviously given it some thought here. And, I like the idea that he put the foam in between the two of them, It's a little vague at the end how well it works. It's hooked up. Let's put it that way. It's hooked up. He shows the cold air coming out. I think he's not completely finished with it. Man, the comments, the comments on this one, they're just so mad at this dude for daring to misuse a window air conditioner. And you know what? Like, he never says it's going to be perfect, but if you have this old busted window air conditioner and you got a shed and you want to give it a shot, like, have fun, man. Clearly he's having fun. And I know, like there's some people chime in with totally valid technical concerns, like the fan in the window unit isn't powerful enough to push the air through the ducts, which means it's going to freeze up, and I'm probably, maybe, I don't know. We'll find out, right? We'll find out by part 2 of this video. But what strikes me funny is that this is a hack a day. Like this is like the definition of a hack. This is like an old school hack. Like, this is what I would have expected to see on the black and white picture version of Hackaday in like the early 2000s, And so to me, I love this. This is like a return to form, and seeing a guy just figure something out and put it together with what he had on hand. So it's funny to see these people so mad about it. Like, why didn't you just get a split unit? Well, why didn't he, you can say that on so many of the projects. Why didn't you just go buy it? Well, that's not the point, right? Like, you're supposed to make the thing, and yeah, it's probably not going to be as good as the commercial offering, but you made it yourself and it does exactly what you want to do. And more importantly, you learn something, hopefully, along the way. So, it's crazy to see people get so worked up about his projects, because this dude, if this was 2008, he would be the poster boy for Hackaday.
Yeah, exactly. This is a quick and dirty hack, and there is nothing wrong with a dirty hack. That's what it is. Heat pumps are the new hotness in, keeping your house cool. And one of these window air conditioner units is basically just the heat pump, right? A refrigerator is too, if you cut it down enough, right? It's compressing the gas on one side, it's moving the heat over to the other side. He's trying to make it work with his house air, and, we'll see how that goes. See if he can, I don't know what. Is he piping it into his home's ventilation unit, or is he just trying to cool the garage, or...
it appears that's the end goal, is that it's good. That's not covered in this video, but he kind of mentions it really quickly that the reason he's put it in this particular hole in the wall is because the heating system is right there, and it'll be like a short,
So
he's gonna
slurp in the cold air and push that up to the rest of his house.
yeah, he's gonna pop a hole in the side of the furnace and just like duct this into it.
Oh, lovely. Lovely. I mean, horrible, but but lovely. Probably doesn't pass codes or something, but that's on
Codes?
He's on his own.
We don't need no stinking codes.
Exactly. No, I'm with you on that. And if it's just an experiment, it's no problem.
I think my favorite part about you got to watch this guy's video, because the look in his face when he's describing this, he knows he's gonna piss you off, and I think he loves it. He's got this smirk on his face, like, guess what I'm gonna do now? I'm gonna cut a hole in the side of the house, and I think he knows that there's these professional engineers losing hair watching these videos and just shaking with rage. And it's funny in the comments. Somebody says, like, I should say, there's like, at the time we're recording this, there's 90 comments on this post, which is a lot for like just a regular daily post. Somebody was like, well, why didn't he actually cut the coil and then move the coil inside and turn it into a split? And then somebody points out, like, well, if you do that, then you drain all the coolant and you got to refill it. You really want to avoid that, right? But immediately made me think he did another video that we covered where he did get, I think it was a dehumidifier or something off the side of the road. It had leaked the coolant. So like what he did is like he cut the pipe and he put like a Schrader valve and he refilled it with something.
Oh my
and they went crazy. They're like, you can't do that. You can't refill it. How dare you? Like he was skinning cats or something. They were so mad that he had, did this DIY refill. So, you can't win. Either you retain the original coolant, and don't break the loop, or you fill it up your own. Either way, they're gonna get mad at you.
Well, I think the exact opposite of a hack is the work that NASA does, and this next article is about just how Voyager 2 is going to reorient its dish antenna. And Jenny picked this one up and actually went and found an old NASA technical report, which you can read in PDF, the digital Cannabis tracker. And this is a star tracker, and it is using, again, this is Voyager, so it's using 1970s technology, discrete integrated circuits. You can't say discrete integrated. All integrated circuits, no microcontrollers were harmed in the making of this star tracker, and it tracks one star. It tracks Cannabis. That's the one star that it tracks, but that's enough to get it pointed in the right direction. The circuit itself is completely laid out for you. I haven't 100% gotten what's going on. The logic to make this thing work and, run the cone angle circuit and stuff is really very funny and very old school, but does kind of just go to show what you can do with a bunch of latches, some shift registers, a voltage controlled oscillator, some AND gates. It's that level of old school. But here's the full circuit diagram. I guess I could try to make my own and see how it works and figure it out, actually. That might be really cool. On the other hand, you could probably do it a lot easier in a microcontroller these days.
Yeah.
You think?
It's funny you say, this is what you can do with discrete components. And no. This is what you must do.
This is what you had to do.
This is what you have to do when you have no other options. Like, no one would be like, this is my first choice now, right?
Yeah.
To the point that it's mesmerizing to us. The point that we're bringing it up and talking about it, like, look at what they were able to do with these simple things. Not a CPU in sight. Everybody's just living the moment, enjoying life.
Yeah.
But yeah, it is crazy. I mean, I think that, everybody's been talking about this system and how it's going to kick in October and it's going to reorient, Voyager so it points back at us. I really hope that it does.
I hope it does.
Like, there's been a lot of talk, and like, I haven't seen any talk about like, well, what if it doesn't? You know what I mean? And I think like nobody wants to really acknowledge that possibility because, again, we're talking about a system made of like the lowest of the low tech in the 70s that's now 135 astronomical units from Earth. Like some ridiculous,
Right.
talk about working in an environment that it was never designed to work for. And everything kind of hinges on this thing
Yeah.
waking up and going, oh, wait a minute. Some idiot pointed me the wrong way.
See if
Let
I
me
can
get
roll
back.
over right.
Because they say that this thing kicks in once in a while, but like, when's the last time it needed to, when's the last time it needed to actually make a course correction? Like, so it's been on course and pointed the right way. So
Yeah.
like, what? Sure, okay, maybe it does check every 6 months, but like, when's the last time it needed to say, "Uh-oh, let me spin up and move"? So we could
Yeah.
be kind of in uncharted territory here. And if it doesn't do its thing in October, and they can't, get back to the mission, man.
Yeah, and we've actually had 2 Voyager stories in the last week, right? What you're talking about is how we got in this bad situation, which is somebody issued a bad command, basically, and rotated the thing. I didn't mention that, but I'll throw that link in as well. Voyager command glitch causes unplanned pause in communications. But then how we're going to, if we're lucky, get it back is all relying on this crazy star detector. And so the way it works is it scans around, and when it finds a star that's the right brightness, it assumes it's in the right place. And I have no idea how that's still going to be working after whatever, 50 years. And if you read the technical report, so end of page 2, beginning, I guess there's a schematic in, so it bleeds into page 5.
I hope all the listeners have their workbooks with them.
Everybody turn to page 2. Programmable intensity gates. The programmable intensity gates selected by external command allow a wide range of star intensities to be selected for star acquisition. This feature will be very important on, quote, long lifetime spacecraft missions because of possible degradation of the image dissector tube sensitivity over operating periods from 6 to 10 years. The requirements to have adjustable high and low gates is mandatory. So they're thinking of long term in a slightly different scale than what we're looking at right now. So it'll be interesting. Why Cannabis? It must be it's like the only bright star in kind of a otherwise dark region. I'm gonna have to pull up a night sky map right now and see why the heck they picked it, because this thing is super rudimentary and it's saying, is this star the right brightness? It doesn't have any context. It doesn't have anything. It's either pointing at it and getting the right intensity signal back, or it's not. And to look around, it does a big sweep and it scans a bunch of area. But you have to presume that if it's far enough away, it's going to hit some other star that's about the right brightness and it's going to get confused. I'm holding my breath. I'm keeping my fingers crossed. I do hope it does work, but that's such a ridiculously non-technical way to tell where you're pointing. Is like, this is a star that's just about the right brightness.
So the internet...
What does the internet say?
The Guardian of All Knowledge says that Cannabis is the second brightest star in the sky.
Okay.
Second to Sirius.
Okay.
Number 1 was, I don't know. Number 1, he was busy. Sirius was busy.
Yeah.
Number 2, I'm sure there's some astronomical region. Like maybe they were worried that would be confused for a planet or something, if they're of comparable brightness from a certain distance, So they said, okay, we'll go down a little bit, the measure. And it's it says the brightest in its constellation, so maybe like step 1 is identifying the constellation.
Nope.
And then
Nope.
No.
only thing this thing can do is figure out how bright it is. You're thinking you're thinking too far ahead.
Yeah, I'm thinking like Python and OpenCV. Like no.
This is what you would do if you had a Game Boy camera sensor up there, but you don't.
Right. Yeah. So yeah, like you said, it's literally like, here's a bright thing.
1 pixel. Is it bright enough? Yeah, that's amazing. Anyway, I'm astounded by that tech, and I love the fact that this kind of old documentation still exists. July 1st, 1972. Here we are 51 years later, looking at it and hoping that this thing works.
I saw somebody on Mastodon, or they were like, the Voyager was launched in 1977. That must mean it's one of the oldest still functioning computers. And I was like, go to a vintage computer festival. They got Tandies that got that many miles on them. And people are still playing games on them.
Yeah.
Yeah, but to be like, yeah, not only is it one of the oldest ones, it's the oldest operating one. Like,
Yeah.
not quite.
How about maybe the oldest continuously operating one?
Well, yeah, I would imagine that. Although there's probably still somebody been playing their games on their retro computer that long. Oh, and in an unexpectedly apt segue, speaking of retro computers, I picked this one. It's actually one of the ones I wrote up, and it's OLED display lets vintage PC engage turbo mode in style. What's interesting to me is that, I'm cheating a little bit because the other one was like last week. But we had 2 turbo mode projects in a very short amount of time, a few days apart from each other. And we've kind of noticed this trend sometimes when, like, I think the thing is when you put a post out there and talk about somebody's project, it's only natural for, like, other people to be like, oh, man, I made something like that. I should have sent it into Hackaday. And then they send theirs into Hackaday or one of their friends does or whatever. So, like, these things tend to come in duplicates or triplicate. And this is kind of what happened here. The cool thing with these turbo buttons, I suppose we should wind it back for those who weren't using computers when Voyager was launched. There was a time when, 66 megahertz was blindingly fast. If you wanted to use software that had been written for a much slower CPU, that became a problem. So they put a turbo button on the face of like 486s and those kind of machines, which was not so much a turbo as the inverse. It would slow the thing down so you could run your old software written for 8 megahertz or whatever. Once you were done with whatever that was, you could hit turbo and, bask in the glories of Windows 3.1. And the interesting thing with these turbo buttons is that there would be a light or something on the case, right, to tell you that you were in turbo. And the fancier 486s would have a little numerical display that would switch between like 66 and I think the ones that the 2 here are like 66 and 33 or something they switch between. But the interesting thing was, even back in the day, they didn't actually measure the CPU frequency. It was just a light. You would configure the display with like jumpers on the back usually to match your thing, because it would just know you were toggling between 2 states, right? It didn't know what those states were, because the electronics involved in actually measuring the CPU frequency were complicated and unnecessary, frankly, because you just needed to know if a light was on or not. And both of these projects do the same thing, but with an Arduino. So the LED, like the legitimate turbo LED from the 486 is hooked up to a pin on the Arduino, and if it goes high or goes low, it makes the display do the thing. What kind of strikes me about these two, I mean, they're cool projects on their own, but they're super, super similar until they're not. Right? Because they both use the Arduino and they both use the same common principle. I wouldn't be surprised if there was some ancestor between the 2 of them, right? But both people probably looked at the same project somewhere down the line and were inspired. But the real difference here is that the one this week is using an OLED and has like cool graphics, has like the logo for the 486, so it switches back to a 8088, if you're in the slow mode. It's very like what we do now, right? You're using that microcontroller for everything it's worth, Whereas the old one, the project from last week, it wanted to look authentic because it used like a 7-segment LED display. And it's kind of a cool example of how, just a few lines of code and, maybe one different component can make a vastly different end result. And in a way, it reminds me of how a big complex project is sometimes hard to wrap my mind around. So if you look at it in smaller, like incremental steps, it's easier to get started. So they could easily have been the same project in 2 different points in time, if that makes sense.
Yeah.
Easily we could have took the earlier project that then like in 6 months evolved into this. Once they're like, ooh, wait a minute, I have an Arduino that's sitting here doing nothing 98% of the time. Maybe I should have it run some animations, So it's just interesting how these 2 projects are very similar, but at the same time, because the respective creators had different goals and different visual styles, I guess, the end result seems much more different than they actually are.
Both of these projects say that they're just reading the status of the LED
Right.
there. Are they actually reading an LED? Is there like a light sensor in there too? Or are they just reading the voltage on the pin?
I believe both of them actually have they just took a line off the back of the LED and put it onto one of the GPIO pins, So it's actually reading a digital. But yeah, I suppose you could do a little light sensor.
I want like a photodiode in there glued to the LED. Okay, fine.
Yeah, so that there's nothing touches the original electronics. Everything's still stock. Yeah, that would be the Vintage Computer Festival version of doing it, where you don't want to, you can't cut into the original wires. They're older than Voyager. We can't cut these wires, but but we can put a light sensor in front of it.
Okay, that's fine. I'm fine either way. Yeah, I mean, they could have just, I guess they did in previous incarnations of this, just use an LED instead of like making a fancy display. But the fancy display is just like, you know, when you're going from 25 megahertz to 66 megahertz, the fancy display is just like bling, you know, it's just showing off. It's like, oh, look at this flex. So I do kind of appreciate that.
And I'm sure it was marketed probably as a upsell too. Because you probably, when you ordered your 486, you're like, well, do you want the blinky light or do you want to see, you know, the 2-digit display? It's like, ugh.
Press the turbo button.
It's only another $300. If I'm already spending $1,500 on this 486, I might as well. Let's look at all the features.
The extra chrome trim on the outside and the turbo button.
But when you buy a 46, you're buying it for life, though. So you gotta
That's true.
Put the money in.
Yeah, exactly.
It's not like this technology is going to evolve at a skyrocketing rate, right?
720K should be enough for anyone. All right, my first quick act this week comes from Mr. Innovative. Automate your pin header chopping chores away. This is a sweet little machine that cuts off a given number of pin headers. You know, so you want 5 in a row, you want 7 in a row. It automatically pushes them out, and then another motor driving a little cam pushes hard up against it and snaps it off. I really love the little tongue that pushes the pin headers out until they're the right length. He has it roll up inside this little spirally snail shell thing so that it's not just dangling out in the open. I think that's a sweet detail. Next up, cook up a yoke in 5 minutes, and this is yoke like flight yoke, KJ7RRV. This is totally a hack. Comes from the Flight Gear forum. This is looks like a paper towel tube with a flight yoke attached to it, but it's then mounted in some cardboard, and he puts a mouse on top of it so that he can use the mouse's X to sense when the yoke's turning sideways, and he can push it in and out, and that activates Y. This lets you play flight simulators with it. He says it drifts a bunch, so he's also added an extra button that recenters it when he needs to. But other than that, it's hard to beat for a flight yoke made of cardboard. And last up, brick technology. What does it take for a Lego car to roll downhill forever? He makes an inclined plane and then a treadmill on it and wants to roll a Lego car down it and just match the speed. And that turns out to be a difficult problem. And he does it at a whole bunch of different angles, and you get to watch this video increasing the amount of friction so that the car doesn't roll down the hill too fast. And then in the end, he actually ends up having to increase the traction. And so he's got a fan pushing the thing into the treadmill. It's just a lovely little demo of all of the physics and the kind of unintended consequences of trying to engineer something without being able to use a PID loop.
Can I just say, before we continue,
You can.
Cooking up a yoke in 5 minutes
It's horrible.
it's got to be one of the best titles I've seen on Hackaday in so long. I couldn't stop laughing. The mental image, and it worked so well. I gotta give Brian credit for that one. Cook up a yoke in 5 minutes is
correct.
Once in a while, like the stars align. You know what I mean? My first quick hack for the week is solar-powered Game of Life follows the sun's rhythm. This is a really cool take on the Game of Life, which, I can't even count how many times we've covered that. But the idea here is that the ESP32 that's running the simulation calculates the state of the game, outputs the current play field, or whatever the real term is, to an e-ink display, and then goes to sleep. And then a solar panel charges up little battery, and when it hits 3.3 volts, enough for the ESP wakes up from its using the ultra low power sleep. It wakes up, calculates the situation again, outputs it, goes to sleep. Repeat until the heat death of the universe. And what you have is a game of life that is synchronized to how much light is in the room. Brighter it is, it can update almost constantly. If it's in a room that doesn't get a lot of light, maybe it only updates every day or week or whatever. So it adds an interesting kind of variability to what, despite being called game of life, isn't exactly a biological simulation, So it's kind of cool. It turns into not only more of a life simulation in a way, because these things are responding to light, but it's just like a cool piece of wall art that I might have on my own walls soon after watching this. Next up is Pixel Pump. The open source vacuum pickup tool is now shipping. This is a really cool project that was actually entered into, I think, the 2021 Hackaday prize. It is a little vacuum tool for picking up tiny surface mount components. Conceptually, there's nothing really groundbreaking here. I mean, it's just an open source version. It's got the foot pedal and everything. Makes it easier to work with the parts. It's just one of those things where it's like, hey, that's cool. Can we make one with a bill of materials and, design files you can download? They brought this, I guess, to last year's Supercon 2022. It was there in the alleyway, I remember.
Yeah.
And I remember seeing this thing, and it is just so beautiful. That was the thing that really, my biggest takeaway, I kind of blanked out even on what the thing did because I was so mesmerized by how gorgeous it is. I mean, it is just so cool, and to think that this is made in his home. This is it's a very high-end DIY project, but it is definitely just something that anybody who was suitably engaged could do. And I think my favorite thing about it is that he went through the trouble of designing the enclosure so that every outward facing side could be printed face down on the Prusa textured bed, so that the whole thing has that really cool textured hammered metal look. And the effort to do that is insane, but wow, the end result is phenomenal. And in a similar vein, my last one for the week, a vacuum chamber gets automation. This comes from Nick Poole, which of course, Hackaday Supercon attendees or Hackaday readers will certainly recognize the name from his projects. And one of the things that we've been doing recently is custom vacuum tubes. I think the Supercon talk was on custom vacuum tubes. Come up with a machine to help make the vacuum tubes. Frankly, I'm not so interested in that. I'm interested in the baller front panel that he made for this machine. It is so gorgeous. And I actually have been kind of following the posts on Mastodon that he's been doing for this. And it's actually, it's a PCB. And I guess I don't know why I ever thought of doing it this way, but the whole front panel is a PCB with the silk screen, saying what all the stuff does. And then the buttons and the LEDs are just soldered directly to it. And so it looks beautiful because it's all high res, you can't do this at home, right? There's all high res artwork and stuff on it. But I think my favorite part is that there's a little graph of the vacuum system on the right-hand side. And it's done like the the badge life thing where it's just the substrate of the board with the LEDs behind it. So it glows, so when you the vacuum pump is on, that section of the graph glows, and it just looks so cool. It looks so cool. I want to make something so complicated that I require a front panel like this so I can steal this idea. And I also have to say, it's got a scram button like a nuclear reactor, and I wish more projects on Hackaday had scram buttons. So if you want to make sure your thing gets written up, even if it doesn't do anything, just put a scram button on there, and I'll see to it that it gets on the front page.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week I wanted to feature Lewin Day's Ask Hackaday, What's the Deal with Humanoid Robots? And this is one of those kind of evergreen topics for us because people keep wanting to make large companies keep wanting to make humanoid robots, and I have no idea why. Last week, there were a few in the news. Tesla was touting its Optimus robot again, and there was news that Intel had just tossed a whole bunch of money at Figure 01, which is a humanoid robot startup. Everything I've seen from them looks rendered, of course. And Sanctuary AI has one. And I think part of what's going on here is that there is kind of an AI spin being put on these. And so it's all of everyone's science fiction dreams coming together in one thing, right? It's like C3PO and a chatbot in the same thing, which is, I guess, what C3PO was. So it's like it's totally like everybody's non-realistic sci-fi dream of what robots should be. That's basically the take here too. Lewin concludes, I guess as a bunch of us have, that if you had a task you wanted a robot to do, you'd actually just design the robot to do that task, not to look like a human. If you maybe had to design a robot that had to work in spaces that were mostly populated by humans, that would be maybe why you'd want the robot to be like a human, because it would fit in better or something. And, people in the comments come up with, well, you have to build legged robots if you want them to climb stairs. That's, of course, totally crazy. Wheeled robots climb stairs just fine. You just need big enough wheels, or, the ability to shift the center of gravity so that it can put pressure on the right wheels at the time. Man, if you think climbing stairs with a two-legged robot isn't a difficult problem, it is. It's a very difficult problem, and it's actually much easier to handle that by just having, more wheels. So, I say, If there were any good way for us to have evolved wheels, I would totally wish we could have.
Well, this is a bug with gears that evolved in its wings, right? So I suppose
right?
It's not. I suppose it's not completely out of the realm of possibility. We put faith in evolution, so we say, well, this is what we evolved to look like. And we have hands and we have feet and we walk around on two legs, and surely that should be the end goal of our own mechanized dreams or nightmares. I think that it's not true. I think it's a little bit like, when they made the flip phone to look like the communicator in Star Trek, right? I think there's a desire to make our real life technology mimic things.
Yeah.
And I guess in the flip phone, it worked out okay. But I think in this case, it just doesn't seem to work. Lewin has a picture in there, and you have a real robots doing work, and they look like arms. And then you have a silly robot standing up there, and it looks like something from Star Wars. And I think it's going to be a very long time before the Star Wars robot does anything useful, And I guess the middle ground is what Boston Dynamics do. Because they are legged. They're legged, but they're not humanoid, certainly. But they do seem to be hitting goals, right? Like they're at least able to walk around and self-right themselves. And, we all remember them videos of those vicious robot abuse where they're trying to kick over the bots, and they manage to stay upright. But I would still say that four legs would be better than you want to evolve wheels. Yep. We should have evolved four legs. We could be like centaurs or something, because I think it's always going to give you a better footing in uneven terrain. And that's maybe one of the few places where a legged bot might make sense, is that I've seen disaster relief where when you're trying to search the wreckage of a house, wheels ain't gonna cut it. Maybe tank treads, but you never know what kind of elevation changes are gonna be in front of this bot. So the something that can walk around gingerly in rubble could have a real life benefit, right? But that's a pretty narrow use case. I can't off the top of my head think of much else that you couldn't be better suited with wheels or tracks or anything like that. And again, that wouldn't be a humanoid robot. I would expect it to look like the dog thing that Boston Dynamic has. That makes a lot more sense. So yeah, I don't know what the case is for humanoid robots. I think it really just is a desire this. We want to, whether we want to mimic sci-fi or we have some weird, God fantasy of creating things in our image, maybe. But I think that is really it. If there's a technical reason for it, I don't think anyone's really made it yet. You know what I mean?
Yeah, and I think that's it in the end, is that it's humanoid robots for show, anything else if you need to get the work done. And that does actually seem to be what Tesla's Optimus robot is doing the best at right now, is, standing in a showroom and making people go in and say, oh, cool ass humanoid robot.
Yeah,
And
where can I do? Where can I invest? Right.
but the irony, of course, is when you look at their incredibly highly automated and reconfigurable, entirely robot-driven factory line, like, that's a technological marvel. And, like, then you give me this little doll that stands up in the please. It's smoke and mirrors. And if you're going to put AI in a robot, put it in something that at least has a chance of standing up on its own. Man, whatever. What I do know is that Joe Kim's art for this one is absolutely stellar. So if you haven't read this one, you absolutely must check it out. I'm going to have to get that one on a t-shirt.
Well, my pick this week for Can't Miss article is Jenny's Daily Drivers, a FreeBSD 13.2, written by, unsurprisingly, Jenny List. And this is the second in what I think is a really cool series that she's been working on, where she just kind of takes different operating systems for a ride. There was a kind of a criticism of the first one. They were like, well, this isn't a review. They're not meant as reviews. Like, these are literally like, hey, what's up with FreeBSD? Let me install it and let me give it a shot. And I really like the whole concept of the series, and I hope she pushes ahead with them, with all kinds of weird operating systems. But I'm especially glad that she did a BSD and didn't just limit it to Linux distros, because I do think that, BSD really kind of blends into the background noise a lot of times when we don't even, when we think of operating systems, even when I'm going to write a post, I'll always be like, oh, then this works on Windows, Linux, and Mac. Those are just like the big three that we think of, and let's be real, it's big one and it's far smaller 2 and 3.
Exactly.
So the BSDs and stuff, like, I don't think they even get a lot of mind share from most people, even techie people. So I think it was really cool that she jumped into BSD and sort of gave this kind of, like I said, it's not a review. This is like first impressions, I guess would be the best way to put it. Like, obviously Jenny is a Linux user long time, like most of us. So she kind of comes at it with this Linux mentality, and, there's an interesting kind of compare and contrast there in terms of like setup and that kind of thing. She comes away, spoilers, if you didn't read the whole thing, she comes away very impressed, and she really liked the experience, and she liked how, you really do, especially, her first one was for Slackware, right? So Slackware is also a pretty bare bones setup, and this was similar in that respect, where you really are expected to, know your way around things, and you're kind of given a clean slate, and what you do with it is really up to you. Like, you're not, pushed into any kind of pre-configured setup. It's like, here's a basic operating system. We're going to give you the stuff to work. And I think for a lot of us, we appreciate that. I know I, for one of the many things that bothers me about Windows is that it's really the kind of thing where, like, you are expected to work the way it wants you to work. Everybody must enjoy computer time now. Enjoy computer time. And it's this, like, assembly line mentality, right? Whereas, I want to do things the way I want to do things and have that freedom, right? So BSD, it definitely gives you that. And I think that's very appealing for a lot of people. Articles like this kind of just call that out, right? You might not have, it's possible you never even heard of BSD before, or you heard about it, but you thought it was some weird server thing. You didn't even know that was desktop, and of course there's other BSDs too. And I don't know, I don't want to speak for Jenny if she plans on doing NetBSD or anything like that, but I think just the fact that we got this out there is going to help, and I think it'd be really cool if people read this and said, well, hey, let me give it a shot, let me give this a try, especially in the modern era of being able to emulate a whole computer on your wristwatch. Like the barrier for entry is much lower than it used to be, although to be fair, Jenny is doing it on real hardware and not a VM or anything. So yeah, it's a really cool series, and I hope it runs for a long time, and I hope that the operating systems get increasingly weird, because frankly, I think if it was just different Linux distros, I think that would get boring quickly.
Everybody has different preferences about how fancy they want their system to be, and how many graphical user interface things versus just, pre-configured functioning things. Then Jenny has this thing where she actually screenshotted the straight up vanilla X Windows session with the clock and a couple terminal windows. And she's like, it's been a long time since I last saw vanilla X Windows. I type up start X when I log into my computer.
Oh, wow.
I do.
That's a memory. It just unlocked a core memory for me.
I do. It runs a bunch of things that I have in my .xinit RC file. I do.
I did that for years, and then one day I was like, if this is the command I run 99% of the times I log in, maybe I should
just
be a
automate
normal
it.
person and have this
right.
run itself.
That's right.
There's a meme, I don't know if you saw it, where it's like, I guess there's some animated Star Wars or something thing. Anyway, it says like, Linux user turning on their computer. It's some Imperial stormtrooper like starting up a TIE fighter and like flipping all these switches and like typing in code and like adjusting things. And it's like, this whole like startup sequence.
It's a little bit like that. Yeah, I'm going to have to pull a Jenny and just start installing operating systems for fun.
I don't know if that's her intent, but that's what I hope is that people see this and they want to give these things a shot and come out of their comfort zone. And like I said, I want to see the weirdest stuff you come up with. Something I saw recently was like some self-booting 2 megabyte operating system that was really impressive for what the hell it was called. But there's all kinds of crazy stuff out there. I don't know if we're gonna get the Temple OS edition of this thing, but that'll be the final one. That's the final boss,
right?
When you've gone through everything else, you're like, well, guess there's the only thing left now.
Without spoiling it, I will tell you that she's got some weird stuff coming up, and not all of it.
Excellent.
Some of it makes Temple OS look positively mainstream.
Fantastic.
And that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow along with the links or leave a comment, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us an email, tips@hackaday.com. And until next week,
keep on hacking. Is this a cyber deck? I can't tell. I think maybe not, but I love it anyway. Oh, okay. We'll have to look at these later. Taking a valuable podcast time.
I got nothing to say about that. But I don't know. I'm spitballing. Probably shouldn't.
I don't think it's a medical issue. I don't have any symptoms in the traditional sense. I just feel defeated.
Automate your pin header.
Here's some simple stuff that a crazy person did.